Hello everyone, this presentation focuses on the recent engineering innovation, terahertz radiation. So let's get started. Alright, for some background knowledge, terahertz radiation is a form of electromagnetic radiation such as light, microwaves, and infrared light. The main difference is that terahertz radiation is not harmful to biological tissues, meaning that this radiation can be used on almost anything or anyone. There exists a variety of applications as well, which will be explained with better detail throughout the PowerPoint. Very little was known about terahertz radiation back in the late 1800s, or even general science for that matter. Terahertz radiation was discovered by Professor Heinrich Rubens in 1895, as pictured to the right. It is believed that terahertz radiation's original use was to produce spectrometry of objects. Not near the quality of today's images, though. It was also unclear if terahertz radiation was dangerous or not back then. Terahertz radiation was determined to be non-harmful due to its non-ionizing properties. This has to do with terahertz radiation's inability to change the molecular structure of objects, which is a good thing for us. This form of radiation can distinguish between cancer and non-cancerous cells, meaning it is a useful tool when checking for cancer. It can also produce images of cells, and specifically individual parts of cells, with greater detail than a traditional light microscope. It can definitely be concluded that terahertz radiation has its stake in the medical field. Moreover, terahertz radiation can be applied to security. The special properties of terahertz radiation, such as penetrating power and fast image production, allow it to distinguish between a variety of materials, something that X-ray machines and traditional medical detectors cannot do. When integrated into airports, this allows for safer travel and overall better homeland security. We can also see terahertz radiation becoming increasingly apparent in manufacturing and industry. Terahertz radiation can be applied as a method of quality control due to, again, the efficient imaging production and the ability to see inside packages or freight. Using terahertz radiation here would eliminate the need for cameras, lasers, or even quality control personnel, improving the efficiency of the manufacturing company. This means faster delivery, lower costs, and overall a more prosperous commerce sector. Terahertz radiation has proven its known abilities, and now thanks to AT&T, it's proving one more. AT&T showed that terahertz radiation could be emitted in short pulses, which would allow for the wireless transmission of data. This has the capacity to open up an entirely new form of communication aside from traditional Wi-Fi, radio, or cellular networks. There is no doubt that terahertz radiation is a recent engineering marvel. With its diverse range of applications and its surprisingly low amount of cons, we should definitely see this innovation making headway to becoming a common practice in many fields. Thank you, and I hope you enjoyed the presentation.